Okay, so let's pick up where we left off with our calculator application. In the first video, we saw how we started from scratch from a new project, and we used a test-driven approach to create a calculator, which at the moment isn't doing too much, but we've seen how we can use the tests to drive out both the design and the class naming, the return types, and the implementation, i.e. the stack-based approach. And we saw how the tests can enable us to refactor both the application code as well as the test code itself. And now in this video, we're going to look at actually adding some real operations to our calculator. So let's start with an add method, an add operation. So test-driven approach, so no application code yet, we're going to write our test first. So at the moment we've got two test classes. We've got the new calculator test and the calculator with three values test. So where are we going to put our add operation, our add test? Well, it doesn't really seem to fit into either of those two. For testing the add operation and also for testing other operations we may want to add, we want a calculator that's got two values in the stack. So we haven't got anything with any test setup like that, so let's create a new test class. So, new class. Want this to be in our test folder. So, as we can imagine, adding a number of different operations to our calculator, let's create an operations test. Okay, so I'm going to jump right into creating a field here for our calculator, and then we'll add our test setup. So what kind of calculator are we creating in our setup? We're going to be creating a calculator with those two values that we can use to test a number of operations. Initially just the add, but then we'll move on to other operations too. Okay, so let's have a new calculator here and put a couple of values onto a stack. So set the accumulator to the first value. Let's say 20, doesn't matter too much. I do try and use different test values across different tests just to keep a bit of variety there. It helps to flash out any issues you've got in your application code using a range of values rather than the same set each time. And it can also make it easier to spot problems when tests are failing too. So let's enter that value and set the accumulator to our second value. I don't know, what should we go for this time? Let's go for 4. Okay, add our annotation here, so let's run before all of our tests. Let's sort out our imports, and now we're ready to create our first test. So we said we wanted to implement an add operation, so let's have a test for that. Okay, so our calculator has already been created. We've got our two values in the stack. So let's tell our calculator to add those numbers together. Okay, and what that operation is going to do, it will add the numbers together, form the calculation, and the value of the accumulator will now be the result of that add. So in this case, we expect it to be 24. So let's just test the value of that accumulator there like so. This is a new test class. We're just going to have to fix the imports to get the annotations and the assertions. And now we can see, as with our other tests, made tests before, the test is now not compiling because we haven't got our method. So let's use quick fix as before and create our add method. Okay, so again, TDD approach, red, green, refactor. Let's see if we've got our failing test. Okay, great, we've got our failing test. We're expecting a value of 24. Because we haven't done anything, we haven't changed the accumulator, the value is still 4. So let's go ahead and implement this method now. So, what do we need to do? We need to get the most recent value from the stack first, which we can do quite easily using peek. We need to take that value off the stack. And we now need to get the value that is now at the top of the stack. Okay, so now we've got our two values, we can perform our operation, and we want to replace the current values at the top of the stack, which will be value 2, with the result of our calculation. Let's see if this works. Okay, fantastic. So, very quick, we've added our new operation, our add operation. So, whilst we're going, why not add another one? Let's go for -2. Go for the obvious one. Okay, so back to our operations test. Let's add a test for minus. Subtract. Okay, so in this case we expect the value to be 20 minus 4, so 16. Okay, same deal as before. Fail and compile. Create the empty method. Run the test. Failing as before, and now we're free to implement. So this time very similar to the add method. Get the two values at the top of the stack and replace them with the result of the calculation. So let's just copy that implementation across there. This time we want to be replacing it with the oldest value on the stack, which is value 2, minus the most recent value on the stack, value 1. So value 2 subtract value 1. Okay, let's give this a go. Running our tests again, great. We can see it's now passing. So we can see here using a test-driven approach, we can quite rapidly add new features to our calculator class. Okay, so just looking at the design of calculator now, so TDD following the red-green refactor approach, I just want to think about whether the design of calculator is really as we want it to be. So at the moment, our add and subtract operations, there's a bit of code duplication there, and also adding a new operation to the calculator is a new method for each operation. Not too sure I want it to work that way. I'd quite like the calculator to be a bit more flexible, so a bit more extendable. Maybe we'll even allow the ability to register custom operations with our calculator in future too. So, want to refactor the calculator. How could we go about changing our add and subtract methods? So it'd be quite nice if the operations themselves were generic operations. The calculator knows how to execute them, but it doesn't need to know what those operations are doing. They're just operations that happen to operate on that stack. So let's look at creating an interface that represents what an operation is, i.e. something that operates in a stack, and let's look at converting our add and subtract methods into implementations of our interface. Okay, so what do our operations need to do? As we said, they operate on the stack. So let's create an interface for an operation. So I'll create the interface. Want it to be in our main source tree, and as I said, it's an operation. Okay, so what do we want to do? As we said, it's an operation that can be applied to our stack. Okay, I think that sums up what we want our operation to do. Okay, so first let's look at the add operation. do one operation at a time, using our tests to validate our refactoring is working as it should. So we want to be creating an add operation to replace this add method here. So let's go with a new class in our main source folder, and as we said, add operation. Okay, and we want to implement our operation interface. We should be able to take out all this code here and replace it with our add operation implementation. Okay, so we're going to instantiate our operation and apply it to our stack. So now we can paste in our code here, and we would expect this just to work as is. Quite a simple cut and paste here of the method implementation. So we've already got our tests, so let's run those tests and make sure they're still passing. Okay, fantastic, still passing. Add operation still working as it should. Let's do the same thing for the subtract. So, new class. Subtract operation. Okay, going back to our calculator. Let's look at replacing this implementation here. Okay, and let's paste our implementation in here. And again, we should be in a position where the tests are still passing. Okay, so our tests are passing. We've managed to split our add and subtract operations out from methods in the calculator itself into separate classes. At the moment, we've still got a bit of duplication between these two operation classes. So both operations are still containing this block of code here, which is common, and they both replace the value at the top of the stack with whatever their calculation happens to be. So it makes sense to try and remove this code duplication if we can. So let's introduce a base class that's going to implement our operation interface that both subtract and add operations can use. New class. What are we going to call this? Well, this is for a particular type of operation. So both our subtract and add operations, they are what's known as binary operations. So they take two inputs, two values, and they're producing one output. So let's create a binary operation class. This will be an abstract class, which will form the base class for subtract and add. Okay, so we're going to implement the operation interface. Let's just go back to our subtract operation and just copy this out here. Okay, so looking at this, what's the common bit of code here, and what's the bit that's specific to the operation? So it's only really this bit here which is specific to either subtract or add. Okay, so we're going to create an abstract method now to perform the actual calculation itself. So this will be a method that returns a big decimal and takes two big decimals as inputs. Okay, and all apply is going to do is going to use that calculate method and replace the value at the top of the stack with whatever that returns. Okay, so this is our our base class. Let's look at changing subtract operation first. Okay, so rather than implementing operation, we want to extend our new base class. Like so. Okay, so for our calculation, we want to be performing the same calculation we were before, up here. So let's just take this here and return the value of that calculation. So we can now remove our apply implementation too. Okay, so subtract is now a lot simpler, and the only thing it's concerned with is how to perform that actual calculation itself. So before we go ahead and do the same thing to the add operation, let's just make sure our tests still pass, which they do. Okay, so let's go ahead and do the same thing to our add operation. Okay, so this time, this is the calculation that we're performing. Remove the apply as before, and make sure our tests still pass. Okay, so we've now managed to improve our operations. We've removed the duplicated code between those two operations, and our tests again have allowed us to do that refactor by serving as a regression test for the calculator for those operations. Okay, so back in our calculator, what else might we look at adding next? Well, we said we wanted to support a more dynamic way of executing operations in our calculator. We don't want to have a separate method on the calculator for every operation we want to perform. So rather than being separate add and subtract methods, let's look at changing calculator so that we can just pass in a string which describes the method we want to execute. So let's go back to our operations test. Now, I could go ahead and change the test add method here to use a new method, but what I want to do is, rather than making too many changes at once, I want to create a new test method which is going to test the new mechanism, and then once that's passing and working, I want to remove the old mechanism completely and make the old test redundant. Okay, so as we said, we wanted to pass in a string which tells the calculator which operation to execute. So we'll just ask it to execute the addition like this. Same assertion as before. We're not changing the logic here, we're just changing how we ask it to execute that method. Okay, so compile error as before. Let's go ahead and implement that method and verify we've got a failing test. Okay, so quite obviously our test is now failing, which is good. So let's go ahead and implement this again in the simplest way possible, with the test driving our implementation here. So let's just call add. That's the simplest thing we can do that will make our test pass, which it now does. Okay, so going back to our operations test, we'll do the similar thing for subtract. Okay, so I'll ask it to subtract the two numbers from each other. And again, the assertion exactly the same as it was before. Okay, so let's run our tests now. And we can see straight away the subtract test is now failing because we only told it to add things. It's not actually checking the operation we asked it to execute. So this again is another example of allowing the test to drive our implementation here, to drive our changes. So, back to the calculator. So we need to be checking our string here. So let's just rename this. Call it operation. And we'll add in the relevant tests to check for the add and subtract strings. Okay, so running our tests again, we can see it's now passing. Okay, so we've added the ability to dynamically request which operation we want. So we're going to look at removing the add and subtract methods now. We don't want two ways of being able to perform the same functionality. So let's create an operation local variable here. So if it's plus, operation is a new add operation. Passing in a minus, the operation should be a new subtract operation. Okay, so now we've got an operation. Let's apply it to our stack. Okay, we've still not removed the old methods at the moment, but they're no longer used. So let's just delete those. Okay, now we're seeing a couple of compile errors. So going into these, we can see we've still got our old test methods here. So we're still testing both ways of performing both the add and the subtract. So these tests here are no longer valid in any way. So let's just get rid of those. Okay, so now let's run our tests again. Great, we can see it's passing. So now we've eliminated the old style method of having a separate method on our calculator for each operation. The only way now is this dynamic method here. Okay, so I'm going to leave this video here for now. So now I'd like to leave an exercise for you to complete. The project as it stands is available for download as a zip. And I'd like, using a test-driven approach, I'd like you to add multiply and divide operations initially, and then go on to add unary operator. So unary operator, rather than the binary one, takes one value, one input rather than two. So let's add a square operator to square the current value of the accumulator. So 4 would give you 16, 3 would give you 9, etc. And then I'd like you to add the ability to register custom operations with the calculator. So the calculator class will no longer need to be modified in order to perform new calculations.